Thank you, everybody. Am I being heard? Frontend Microservices. Hot topic. Actually, Liad in his keynote covered half of what I'm going to talk about, but it's good to hear about it again. And I'll also be talking about the why. A little bit about me. I'm really old. I go all the way back to the 80s. I'm a developer at heart, always was, tried the whole management thing, didn't like it. Things I love are extreme modularity, talking about modularity, we'll be talking about this, and testing my code, we'll be talking a little about that. I'm currently an architect at Roundforest. We are hiring. A lot of what this talk is about is things I'm doing at Roundforest, by the way. And what we do is we build complex shopping sites designed to simplify your buying decisions. Caveat emptor, Latin for buyer beware. I am not a front-end developer. I'm a back-end developer. I know my front-end stuff. I know React. I understand CSS. I'm not bad at that. But what I do, but I am a back-end developer at heart. What I do know about, I think, I hope, for the company I work with, is front-end architecture. And this is a front-end architecture talk. So still, buyer beware. As I said, microfrontends, the whole thing we're going to talk about, we are doing it at Roundforest very successfully. I love the way it worked out. And this talk is not about just the how. It's also talk about why. Why microfrontends and what constitutes a microfrontend, because there are many ways to do microfrontends. It's currently a hot topic. It's trending. We don't exactly know how microfrontends are going to turn out. Maybe there are going to be multiple ways of doing it. I'll be talking about and giving an overview and talking about the specifics ones we're doing at Roundforest. So let's start about the boring part. Why do microfrontends, except for the fact that they're really, really cool? Okay, but before that, what is a microfrontend architecture? And I went to Martin Fowler. I searched microfrontends in Google, and I went to Martin Fowler. So what they're saying is, lately we are seeing attention being paid to the overall architecture that is necessary for complex modern web development. In particular, we're seeing patterns emerge for, and this is the important part, decomposing front-end monolith web apps into smaller, simpler chunks that can be developed, tested, and deployed independently. We call this technique microfrontends. So it's about breaking your huge, humongous monolithic app into chunks, modular chunks, where each chunk can be developed separately, tested separately, and I think most importantly, deployed separately. Why is that important? Why do we need to break our architecture, our app, our monolithic app into chunks? And the answer is, well, first of all, a lot of developers will tell you, don't start with microfrontends. Start with a regular app, and when you grow too large, then do microfrontends. Only useful for Wix-sized apps, too complex to build. Well, those same developers are the ones that say, don't start with microservices in the back end. And I say, in Hebrew, chalta balta. I think it's wrong. Microfrontends are there for one reason. We are all idiots. Seriously, me included. We cannot comprehend even a medium-sized app in its entirety. We just cannot. We're not built for that. Too big. We need to break our app up in order to deal with it. And if we don't break it up, we get spaghetti. We get spaghetti code. And you've all seen spaghetti code, all of you, including me. And this is how we look like when we deal with spaghetti code. We start getting slower and slower and slower in our development. And that is why we need microfrontends. It's not just for Wix. It's not just for Duda, who has these humongous million-sized code web apps. No, it's for all of us. As I said, it's also good for medium-sized apps. But why? Because modularity is the key to keep code bases clean, to keep code bases understandable. So stop, please. Everybody's talking about clean code and Uncle Bob and all that. Please stop. I beg you. Micro-cleaning your code doesn't really help. It's lots of fun and lots to talk about. Stop cleaning your code and start modularizing it. Much, much, much more important. And the most important tool for front-end apps to modularize it is microfrontends. We're not done with the why. So we talked about modularization. There's another thing to talk about. The horrors of front-end. I was amazed when I heard a talk about Wix build times being tens of minutes just to build. So you just want to run the app, see it, 10 minutes, 20 minutes, 30 minutes build time, crazy. And they built this whole thing with Kubernetes and pre-rendered whatever just to deal with that simple issue. And testing times are horror too. If you write tests, then you run tests for half an hour to test the whole app. This for me is a horror story. This is not a good way to work. Let's talk about building. What is building in front-end besides taking TypeScript and compiling it to JavaScript? It's also bundling. Liad talked about that. It's taking all our modules, which we import recursively, and bundling them into one big app. And the more files you have, the bigger your app is, the more bundling times it takes. There has got to be a better solution, and there is. Build your apps with microfrontends, because each microfrontend is built separately. So if you're working with one microfrontend, you don't have to build the whole app, just that microfrontend. And it works in the backend. So if it works in the backend, it should work in the frontend too, right? Let's talk about testing. Testing takes time, and they're flaky, those front-end tests. And the more functionality you have in your app, the more tests you need, the more time you have. So monolithic apps have lots of tests and flaky ones. So people tend not to test. That is why we all not test front-end apps. It's just too much. Better solution? There is. What is it? Microfrontends. Because if each microfrontend is separate and you can test each separately, then you don't have to test the whole app. And it works in the backend, microservices, so it should work in the front end. Last thing is deploying. You want to do continuous deployment where you're constantly deploying your changes to production. But whenever you want to deploy the change you just pushed to the master, you're afraid you'll get some more changes from other developers because million size a huge big app. Because you can't deploy part of a monolithic app. You can't just deploy whatever you want, whatever you changed. So, and you have to run all those tests, remember? So fear of deploying creeps in, and that's the worst thing that can ever be for an agile company. And there's got to be a better solution, and there is. Build front-end app, microfrontends. Each microfrontend is deployed separately. So if I change one microfrontend, I don't need to deploy the whole app. And it works in the back end, absolutely. So it should work in the front end. So that's the why. Why microfrontends? What is a microfrontend? What constitutes? How do we break up our app into microfrontends? And that's where there are a lot of answers to that question. Liad Yosef, in his keynote, gave a good answer to that. Break it up into components, but there are other ways, and let's talk about all of them. How do we divide an app into microfrontends? Two main ways. Divide them into components, separate components, and divide them into pages. Each page of an app is a microfrontend. So either each component or some components are microfrontends, or the pages themselves are microfrontends. Let's talk about components. An app in this world is a wrapper of microfrontends. Each microfrontend is a component. We've seen it in Liad's talk. He had amazing graphics. I really envy that talk. I mean, it's amazing. Each component, as Liad talked about, can be built, tested, and deployed separately. So you can deploy a new version of a component without deploying the whole app. Components, it's not a button component. Obviously, we're talking about like header and the main part of the application and maybe the footer, things like that. We're not talking little small components. We're talking big, okay? Pros and cons. I'm not a fan, so take this with a grain of salt. The pros is we get fine granularity. We can break up our app in whichever way we want. This is great. And it makes sense for React, because React is so much a component framework. It's perfect for dashboard-style apps where we have a dashboard and lots of components, and we want to build something from that. If I had a dashboard-style app, that is what I would use. But it's difficult to implement because injecting code into a bigger part of the code where that code is coming from somewhere else is very difficult. I don't even know how to do it. Registering the component, pulling them. I mean, Liad made it sound simple, but it is not. Okay? And what if we want, the whole idea of microfrontends is here I have React 17, in this microfrontend I have React 18, and in this microfrontend I have Angular and who knows, jQuery if I want to. But if we do this, it's very, very difficult to use this type of solution to bundle together in a page made from React and Angular and jQuery and whatnot, especially different versions of React. So that kind of microfrontend is very, very difficult in the component world. But the thing that I really dislike is that a component is very much coupled to the app. There is tight coupling between the component and the app. It's not just a very, very simple interface. And components tend to change a lot. And the interfaces between the components tend to change a lot. So breaking things up is very easy. So basically, you need to test the whole app anyway, just to make sure that nothing broke, big time. But they are good for dashboards. I give you that. Pages. You can see where I'm going, right? Pages. Each page of the app is a micro front-end. So login, registration, this page, that page, et cetera, et cetera. It is possible to combine a few pages into one micro front-end. That's not a problem. But basically, each page is a micro front-end. And the coupling between the pages is just the links. You click on a link, you go to the other page. That's the only coupling between two pages. So they really are independent. And each page can be built, tested, and deployed separately, and it makes sense. So the pros are, it's a natural boundary. This is, for me, the most important thing. It just makes sense. It's a natural boundary for web apps. There's loose coupling between the pages. It's just links. You can use React here, Angular here, jQuery here, whatever, because it's just pages. Easy to implement, relatively, obviously, and it makes sense for teams because usually teams deal with separate apps. Cons, dashboard-style apps, don't even think about that, and implementing same-page header and footer is difficult. There are solutions for that. So from my point of view, pages are the perfect micro front-ends, which is why we chose them at Roundforest. How? How do we implement micro front-end pages? There are two ways to implement them. One is using single-page applications, and one using multi-page applications. Let's talk about single-page applications. Most React apps today are SPAs, are single-page applications, because that's how we were taught to write React and write Angular and the newfound frameworks. And let's remember how the browsers work. That shouldn't have been so bright. You're in one page and you click on a link. We're talking old school PHP-style pages. The browser gets the new URL, which is /other page, fetches the page from the server, and shows it to the user. Very easy. In an SPA, you click on the link, something in React catches that navigation. It doesn't give it back to the browser. It catches that, hooks into it, and instead of navigating to the page, just changes the state of the React app so that React renders the other page because all the components are in the bundle. And how do micro frontends fit in this? Because this is an SPA-style app. Nothing to do with micro frontends. How do we do micro frontends here? And the answer, each page is a component, right? This is true even in SPAs, in React SPAs. You have the React router, and then each component there is a page. So instead of just rendering the page easily, you can use React Lazy and React Suspend to fetch the page component from somewhere else. Now, the big question is where? Where is that somewhere else? And the answer is, you put it in some kind of an S3 storage, someplace where you have different versions of the app, and the app, when it loads, it knows which is the current version of the page and knows to load that. Not trivial. There's a little bit of registration, what Liad called orchestration and versioning. That's true, but it works. It works really nicely in React. But what if I want to combine React and Angular? What we have today is what we call microfrontend, in this method, microfrontend frameworks, which say, I don't care if you're React or Angular, you're not going to use React lazy. You're going to call the microfrontend framework code, and that will load, if it's a React app or an Angular app, it will load the code for that and have that render the DOM. So there is a way to abstract that so it works with React, Angular, Vue, Svelte, jQuery, by doing something using microfrontend frameworks that know how to deal with the different versions of the framework. It is possible, not too difficult, by the way, once you use those frameworks. This, I think, is what most micro-frontend implementations do today. They use SPAs, they lazily load the pages, and they inject them into the HTML. Not what we chose at Roundforest. 13, okay. Why not? I don't know, I like simple, and this doesn't feel simple. It feels like a hack. It's not webbish. It's not natural. SPAs, from my point of view, are not natural. They go against how browsers work. They go against how the web works, which is why we're trying multi-page applications. Let's talk about that. Since React and Angular came to life, we've basically abandoned MPAs. MPAs are applications where each page is rendered by the server. We've abandoned them. Why? Well, because React in its initial phase, React 1, 2, whatever, was client-side only. You couldn't server-side render it. And having a code that server renders a page in PHP or whatever and then doing it the same thing in React doesn't make sense. Also, when we're talking humongous apps, doing MPAs where you click on a link and then go to another page and render it again, that takes a lot of time. It's slow. And basically, it's much easier to build one big monolithic app. You just pile your code into one app and you're done. And because Gmail taught us to do SPAs. But there's a shift. Liad talked about that. I totally agree with him. The Rich Harris talk he mentioned is really, really good. Go see it. React was client-side only, yes, but now it supports server-side, and and React 18 is going to support server-side in a very big way. MPA navigation becomes really slow. Well, server-side rendering today makes the whole navigation fast. Think GitHub. GitHub is server-side rendered, not React, but it's still server-side rendered, and we all love its speed. Okay. And it's easier to build one monolithic application. Yeah, right. I mean, the whole first part was how difficult it is to build monolithic applications. And Gmail, well, yeah, Gmail, but not all apps are Gmail. Actually, 99% of the apps are not Gmail. And there's a good reason to do server-side rendering, which is SEO. Okay, so the shift is going back. We're going back to MPAs. Liad said it first. And okay, so let's do multi-page applications. How do multi-page applications with microfrontends work? So we have each page is basically a server. And the server renders the HTML. So the browser goes to the server, gets the HTML, and the HTML gets rendered. And then you click on the Click Me button. This goes to the browser. The browser doesn't understand anything. And the browser fetches the page, but it's going to /other page, so it's fetching the page from another server. That server renders that page and gets the new page, and we're good. And yet another server, et cetera, et cetera, et cetera. So each page in a micro front-end MPA app is a web server. It's not that horrible, and we'll talk about it. So each page is a web server doing server-side rendering of the app. And the coupling between the pages is just the links between them. So simple. It's very web. Let's see some code. And I am a backend developer, and because we're talking server-side rendering and everything, most of the code we're going to see is backend code. It's my little revenge thing. And by the way, this is just what frameworks like Next.js do. Next.js, Remix, etc. So I'm going to show the code behind them. And yeah, Liad Yosef stole some of my thunder, but maybe if you see it twice, you'll understand it better. So running the web server. First of all, I do not use Express. Please stop using Express. Fastify is much better, much more secure. Stop using Express, please. I beg you. Stop. Stop. Okay? And then, when I'm asked for slash, I serve the HTML. We'll see how in a second. And I'm going to take all the code, all the assets in the public folder, and serve them as assets. So if I'm getting in slash, I'm serving the HTML. If I'm getting slash app.js, I'm serving the web client.js or main.js or app.js in public. And if I'm asking for app CSS, I'm getting app CSS. So let's look at serve HTML. This is why we're here, server-side rendering. So the first thing we do is we fetch the data from the database or from whatever. This I'm not explaining because each app is different. Once we do that, we render the app. We don't render the app. We're basically rendering the page that this server is rendering. If it's a page, then it's rendering a page. If it's B page, then it's rendering B page, and passing the data as props. Once we do that, we take some HTML template and we inject that string into it. This is an example of an HTML template. You can see I'm injecting the HTML into this div. What is this? And what is this? And let's talk about that. That's hydration. When the browser gets back the HTML, it looks really nice. But if I try to click on things and make it navigate, it won't work. It has no interactivity because it's just HTML, no JavaScript. React event handlers are not attached to it. It's just a static string. It's called dehydrated. It's like they took the water out of it. That's the whole idea. We need to tell React to hydrate it, put back the water, put back the event handlers. So we add a script source to app.js. App.js, and then in the app.js, what we do is we use React DOM.hydrate, give it the same app, and we need to give it the same data. That's a problem, but that is what it is. And that is why we're injecting the data we fetched also into the HTML. There are better ways to do that, but basically this is the way we do it. So that is how we hydrate. We basically rerun the render and make it interactive. To rerun the render, we need to have the data, so we inject the data also into the HTML. To summarize, each page is a micro-frontend, each page is a web server. It does this, and it renders the HTML of the app. It does this by fetching the data of the app, of the page, React DOM.render to string of the React code using server-side rendering, injecting it into HTML along with the data, and then the browser will show the page, fetch app.js so that it can hydrate the page to make it interactive. This is one page. If we have multiple pages, and by the way, I have a GitHub repo showing all this stuff. You can go look at it, run it, etc. This is a structure of a Microfrontends project. We at Roundforest are separating the React code, which is like about page, and the Microfrontend code, which is about page server. Each one is a separate package, but you can combine them together. We do that because at Roundforest we're using a monorepo, so we don't care how many packages we work with. It just works. So each Microfrontend has 2 packages. You can definitely combine them together. Okay, demo time. Like, very quick demo. There's not a lot to show, actually. This is the app, you can see. It's all in the GitHub repo. And we're going to do npm start. By the way, it's using Docker, and it's running these Microfrontends as Docker containers, because, yeah, why not? And then I go to localhost 3000, and there we go, the to-do app. And when I click on a link, this goes to another server and shows the about page. Sorry, I'm not a front-end person, and this was stolen from somewhere else. Not stolen, there's the whole license thing, so I'm OK. And it works, and it's a React app. As you can see, it's really, really fast, and it's really, really fast also, not just in a demo. Our numbers in Core Web Vitals and Lighthouse are pretty good. So what did we see? We see the browser going to /todo, going to the to-do list page server, the server-side rendering, we see the to-do, and then going to the about page server, which is rendering the about page. But let's look at it from the browser's point of view. The browser is going to localhost 3000 /todo and getting to the to-do list page server and going to the about page server in the same place. There's a problem. If there are backend people here, they're going like, that shouldn't work, because two web servers cannot use the same address and the same port. They either need to use a different address or a different port. So this doesn't work. But it does. So how? And the answer is, it doesn't work like this. It works like this. There's a gateway in the middle. Okay, in this case, in the demo, it's just a Node.js app, which proxies the requests to the two Microfrontends. It's just one. It just knows all the routes of all the apps. We use Kubernetes at Roundforest, so we're not using a Node.js app. We're using a Kubernetes ingress. You can use Nginx, whatever. It's a very simple routing mechanism. So, have we improved our modularity? Well, yes. To change the about page, just change these packages and redeploy. You're done. You don't need to test all the others. You don't need to build all the others. You don't need to do anything. You want to change the about page, just change the about page and deploy. And each of these packages is independent. I can understand the about page independently of all the other pages. I can build it independently, so build time is like nothing. And I can test it independently, so test times are 2 minutes, 3 minutes, max. What about deployment? As we said, just deploy the correct page and you're done. Think about it. You have a bug in the login page. You fix the bug. You build and test only the login page. Wonder of wonders. You don't have to run the whole app and flaky tests and whatever. You deploy only the login page. So you know that only the login page has changed. You're very, very happy. And this is the power of Microfrontends. This is why we use Microfrontends, besides the fact that they're really cool. Last thing, wow, 2 minutes, perfect. I want to talk a little bit about an adventure we're doing at Roundforest. I'm not sure it's going to work, but we're going to try. It's dealing with bundle size. Liad Yosef talked about one-way bundling and whatever. It doesn't work with Microfrontends because each Microfrontend is a separate app built separately, so they don't know about each other. There's a problem there. Let's go back. We're missing the hydration. Remember, we server-side rendered the HTML, but remember our bundle, the app.js bundle? It also needs to be script-sourced. So the browser needs to fetch that bundle also and run it, but it needs to fetch it. And that bundle size is big. It's 0.5 meg, 2 meg, 3 megs. It's not as big as a whole front-end app. Okay, it's not like 15 megs, okay, because it's just the page, but it's still big. And it's fine for a single-page application. You just download the 15 megs once and you're done. But in Microfrontend, as I said, each page has its own bundle. Each page has its own 1 megabyte bundle, and that's a problem. But let's look at the hope code of the app.js, of the client.js that does the hydration. Look at those imports. Those are the problem, because if we didn't have those imports, the HTML, the JavaScript would be small. But we do have these imports, obviously. And those imports have imports, and that's what makes the bundling size big. But look at these. Look at these two, React and React DOM. They're shared among all the pages. So how do we deal with that? What if we didn't bundle? What if the import just worked and brought React and app.js and whatever, and the next page, I don't need to bring React and React DOM, so I've saved that. And it doesn't end there, because the app code itself also has shared components, like the design system and React query. So will this work? I don't know. We're at an adventure here. I'm working it with Guy Bedford of TC39 fame. It's working currently in development. We have no Vite, no Webpack, no nothing, no bundling, and it works. This is like amazing, an amazing technology. It's a whole separate discussion in itself. So, summary. Microfrontends split an app into independent modules, not just for large companies. It's more modular, easier to understand, faster build and test times, quickly deploy focus changes, distribute pockets. You can either split by components or by page. We chose MPA. We talked about the reason. I don't have the time, but you can read it by yourself. And I can hear you saying, yeah, works in theory, but it'll never work in practice. My manager won't let me, blah, 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 blah. Well, you're wrong. You know why you're wrong? If you want to know how it works in practice, then we're hiring. Thank you very much.